Okay, I think we're going to go ahead and get started. Good morning, everyone, and thanks for getting in after a quick coffee break. I wanted to introduce our first speaker for today, Simon Thorpe from Twilio. He'll be talking about why using SMS in the authentication chain is risky and what are the better options are available. Simon.
All right, thanks very much. Good morning. So you want me just to give it a couple of seconds on this first screen? 10 as a yes. All right, good morning, everybody. I know it's Friday. I had a few drinks last night, so I hope you're coffeeed up and got some food in you to for the next 40 minutes or so. My name is Simon Thorpe, as actually just described. I've been working in identity and security for about 15 years. I've worked for a bunch of these companies here. I was an Englishman who got acquired by Oracle, and I worked for Microsoft for a bit, worked for a German company called Secud, and then I worked at Okta for a while, all kind of in identity management and security. And then recently I moved to Twilio, where I took over the authentication product they acquired a year and a half ago. And what I'm going to do today is go over how we've been using SMS more and more over the past few years for sending security information, specifically for the two-factor authentication or two-step authentication phase. And so basically I want to talk all about these things. So how many of you in the room here have 2FA set up on some sort of accounts you use today? So we're at a security conference. I'm expecting to see a lot of hands, which is good. And the majority of websites are using SMS to send what is essentially just a one-time passcode. The next 40 minutes is why this isn't a brilliant idea, why it's not very secure, and what from a development perspective to try and do something better than this. But before I dig into all the bad kind of ideas around using SMS for security, I just want to remind everybody that, first of all, we all agree in the industry that username and password on its own is a terrible idea. So if you're building any application today and you're just going to be like, yeah, username and password's fine, that's good for me, I mean, you're pretty much leaving the front door open for a vast majority of accounts. And I'm going to be talking about how SMS was never designed and is not really a good idea for authentication or for security. So that's not very good either. But these two things together are still better than just that alone. So even though SMS, there may be some vulnerabilities, there may be some issues, there may be some usability issues, it is still much, much better than just relying on username and password, which unfortunately, the vast majority of the internet still just relies on username and password. So just keep all that in mind while I try and tear down the walls of fun of security and SMS. So a little history lesson first to kind of just give you an idea of how we got to this point. So way back in 2001, and this is a sample of some of the technologies that have implemented SMS for 2FA, the best I could research, Wikipedia. But there was an open source project I found around 2001, which was sort of the first evidence of somebody taking the idea of a one-time passcode. And the one-time passcode was essentially born from cryptography, and I think RSA kind of started that path where, as part of a login phase, as well as just using a username and password, I need another piece of data that's not as easily shared and not as easily compromised as username and password. The idea of a one-time password with RSA was, hey, here's a token, that token's going to rotate, and based on time, the server's going to have a similar time, and I can use that token to say, well, you must have the thing in your hand because it has some sort of secret that's being used to generate that token that the server knows, and it can compare the two. Say, yes, that looks good. With SMS, it was kind of a bit more, well, you have a device in your hand, I'm going to use that device to receive a similar type of token, right? So a piece of information to that device via SMS, and then as you're logging in, well, if you got that SMS, you must have that device in your hand. So that was the idea, and that was the approach. And back in early 2000 is when we started seeing people building that into some sort of technology. Phone Factor actually were very early in thinking, well, why don't I just provide this as a cloud service? They started building some cloud stuff, and they got acquired by Microsoft around 2012. And then in 2003, RSA pretty much had the market for this idea, but it was all hard tokens. So I don't know if you remember the little tokens you would have in a keychain. Anybody who had more than 4 or 5 accounts would end up with 4 or 5 of these little things on their keychain. And then we blast through the 2000s. Duo then built out another cloud service, and then the technology I work for, Authy, we built out 2012 and we were acquired into Twilio. So this idea has been around for a long time. It's a good 15 years of history behind the idea of sending that one-time passcode over SMS. And if you look at all the sort of implementations today of 2FA, and this was literally just me just fat-fingering a few websites and seeing who's got 2FA, and there's a really good website called twofactorauth.org, which lists a lot of this data. I just piled through that, and some big websites are using SMS for their 2FA process, and alarmingly, Twitter especially are relying on it as their only source for the second factor. Some of these technologies now with Box, you would hopefully argue, yes, but the majority of companies using Box are using an external identity provider, and that external identity provider probably has better 2FA solutions than the ones built into Box. I would hope so too, but it's still alarming some of these big companies are just relying on that one source for their two-step or second factor authentication. And again, this is a very, very small sample. There's lots of people out there doing a wild variety of things. So why is SMS so pervasive? What do all of these devices have in common? They all get SMS, and SMS doesn't require any installation of any software. So even this old guy still works with this methodology. And that's really, really important. So a lot of conferences like this, we're getting into the weeds of security, we're looking at encryption, we're looking at identity techniques, we're looking at monitoring and all these wonderful things. But at the end of the day, if users can't use and log in and have a good experience, it's not going to work. So that's why all these guys have SMS, because it works. It's easy. I can go anywhere in the world, and I can roam with my GSM-enabled device, and as long as there's not too many delays in the system, I can still log in and get that token via SMS. So that's why it's so pervasive, because it's so easy. And unfortunately, we have to accept in security the thing that works for the end user, the thing that's going to get used. And that's why the username and password has lived for so long, because all these alternatives we come up with tend to have some sort of impact to the end user. And I'll get into that a little bit more later on what are some alternatives, because we're getting close to a tipping point where we could potentially be getting rid of that username and password, and we definitely have a better way of doing 2FA that's not just based on SMS. So why is SMS so bad? Why am I standing up here sort of explaining, don't do this, try and avoid it? It's because SMS was never really designed to carry security information, authentication traffic. It was designed for me to say, hey mum, at the pub, coming home in 10 minutes, or your Uber's just arrived, right? It's a notification system. It's a very, very basic way to send a simple short message to somebody else. The guy sat down, designing this, never thought we'd be sending really sensitive security information over it. So because of that lack of design, no end-to-end encryption. I mean, 20 years ago, people wouldn't understand what you meant. What do you mean by end-to-end encryption? Why is that important? But now we've got WhatsApp, we've got Facebook Messenger, we've got Apple iMessage, all of these things, and they're selling themselves on the concept of the message you type here, when it gets to your friend here, we're going to encrypt the entire chain. SMS doesn't deliver any of that. So what it means is your message to your mum saying you're coming home from the pub in 10 minutes goes over all of these different networks unencrypted, totally in the clear. In fact, I remember a long time ago, I think it was as I was working for Dell, there was a friend of mine, a guy working in his bedroom building out some technologies, and he built a solution over SMS that allowed train spotters. Train spotters in England would love to stand on train stations and write down the numbers and spot different trains coming through. And they would communicate to each other via SMS. And he literally had a computer and a modem hooked up, and he sold the service. He was probably one of the early entrepreneurs in technology in that sense. And I remember walking into his bedroom and just seeing his screen fly by. He says, look at what all these people are talking about. Because the whole thing was just in the clear, right? He built a proxy, he was proxying these messages, and he could see everything that was being said, which is fine if you're just writing down a train number. But again, from a security perspective, it's not brilliant. So that information passes over all these networks. And another point with GSM is it's mobile. I can go anywhere in the world, and all these networks agree with each other. Hey, if you're going to roam over there, I'm going to accept your client connecting to my network. I'm going to allow him to route or her to route that traffic back to whoever in the US or whatever country is trying to communicate, and they'll pass all that over. So the networks are literally all over the place as you start roaming the world, and you start building many vendors in there. So as we go through and look at some of the vulnerabilities in the next few slides, remember that some of these vendors you may trust, but if you're traveling to countries where relationships between your culture and that culture and their culture may be very different, some of those vendors aren't going to respect your traffic, and they will happily be monitoring it or diverting it. We've seen quite a few examples of this of late. Also, the actual protocol and the technology itself in sending those messages, it's easy to spoof it because nobody thought that having some sort of repudiation or validity of the source was important. So if you can get in and start messing with the network itself and messing with the traffic itself, it's dead easy just to change signatures and source addresses. And then finally, because SMS became so pervasive and people started using web-connected devices and laptops, etc., vendors started building other ways to get that SMS message. So they built web portals where I can now read all my text messages. And alarmingly, some vendors, some providers in the US, some wireless providers, those web portals are only protected with username and password. So if I find and can get hold of compromised details for your account and I can log into the web portal, now your use of SMS for 2FA, it's pointless because I can just read all that traffic via your web portal and I've already got your compromised accounts. There's a good chance that those two I can go replay against all the other accounts that I'm expecting you to have, your Amazon account, your bank, for example. So SMS really never had in its DNA a lot of good security features. Now, I'm not saying that SMS inherently, the platform is insecure. So let's kind of dig a little bit more into what those bullet points mean from a specific threat perspective. So first of all, the technology that SMS uses to communicate all over is SS7. And that in itself does have security, but a lot of the security of SS7 is what we call a walled garden. So it's not necessarily the protocol, the traffic, the end-to-end connectivity. It's getting access to the network itself that manages all this traffic is pretty difficult. And there was a 60 Minutes, actually quite recently this year, 60 Minutes documentary on how you can get access to this SS7 network and use it for illegitimate reasons. And there was a couple of German guys from a research company that were on the show. They were demonstrating, I think it was the US senator they had. And the US senator says, yeah, I give you permission to intercept my call. You're never going to be able to do it. And they got the phone number. They just asked the senator, what's your phone number? And they were able to gain access to an SS7 network and redirect. I think they actually redirected the voice call and were able to listen to the conversation. Now, that sounds very sensationalistic. That's a word. But what they failed to mention on the documentary was that the German government had actually given permission to the research firm to have access to the network. So whilst this sounds like this is the top of the tree, getting into the network itself, it's not actually that easy. You need to have access to a node within that network. So you've got to get past that walled garden. Believe you and me, most wireless operators are doing a lot of work to protect that walled garden. They have all sorts of monitoring going on, so even if you breach the walled garden, they're looking for the type of traffic where people are spoofing those messages and trying to build their own packets to fool people that they're getting certain text messages or redirect those text messages. However, saying that, there is plenty of content on YouTube. So this is an example of somebody showing how, through a redirection of SMS, they were able to install the Telegram application. Now, Telegram is an end-to-end encrypted IP messaging platform. And there's a video out there quite happily showing, well, no problem, because guess what? To validate you installing that application, they send you an SMS. So you might have this great end-to-end encrypted communications channel, but the way you actually validate yourself into your account is via phone number. There's not a great deal of information about how they did this. We don't know whether they had access to an SS7 node themselves or whether they were through a compromised portal or something of that nature. I'm not sure. But going after this is actually quite difficult, but it's not impossible. And the sort of people that are going to be really vulnerable to this are state agencies, governments, people of really, really high risk. This is going to be a valid way to get through, especially if you happen to be a nefarious vendor who owns access to that network. So let's drop a little bit further into the next kind of threat, because this really is top tier, right? Not everybody, you're building the next Facebook, not everybody's going to be suddenly exposed to this type of vulnerability. Now we come down to the SIM itself. So big walled garden around the actual SS7 network, hard to get into. Let's actually look at the devices, the clients that are receiving that traffic. So one technique is to clone the SIM. If I can clone a SIM, guess what? I can pretend to be your phone and I can receive that SMS traffic. That actually is also quite difficult. Why? I got to get your phone, I got to get the SIM, and actually to clone it, I got to fool your network provider into sending me an unlock message so I can actually then pull the data off the SIM card and copy my own. So that's actually quite difficult to do. much easier just to go down the social engineering route. So SIM swapping is essentially tricking the wireless provider into thinking you're a valid customer and getting them to essentially swap out the account details to a new SIM card. And that's been happening across Europe. I couldn't find the headline for it, but there was a really good example of somebody from, I think they were chief data scientist for the US government, and she had her phone, her phone suddenly stopped working, she couldn't figure it out. 20 minutes later, she realized that her accounts were being hacked, and somebody was essentially using SMS as a vector to recess passwords and also to get the 2FA token to be able to access the sites. And what do people go after? They go after bank accounts. That's where the money is. And when we think of high risk, one of the things our technology does is we protect a lot of Bitcoin. A lot of Bitcoin vendors out there use our technology to protect access to their systems. And Bitcoin is really, really attractive because it's anonymous. So if I can break in, get your Bitcoin account, transfer a bunch of Bitcoin out, it's gone. There's nothing you can do about it. The Bitcoin company is basically just relying on insurance at that point. So SIM swapping is becoming more and more of a problem. And yes, the wireless vendors are doing their best to validate people. But again, it comes down to social engineering is really, really difficult. And the user experience there, you've got to balance, well, if I upset my customers with this half-hour process to validate them on the phone, they're going to move to another vendor. So they have to try and balance how easy it is to serve my customers, my legitimate guys, whilst using fraud techniques and using security techniques to detect the guys who are not legitimate. But really, the top two kind of just get dwarfed by the next two, which are, as I mentioned earlier, there are more and more software endpoints for your SMS. So on my laptop, I can pair my iPhone with my laptop. I can use Apple's iMessage, which takes an SMS and sends it over IP network to my phone, but then ultimately my laptop. So I can be sat on a plane with Wi-Fi, and I can get text from my wife. So that's kind of, Apple would argue, that's pretty secure. But what if my laptop's compromised? What if somebody's targeted me with malware, and they have ownership of my desktop? Now they can see those texts, and now they can put a keylogger. Now they can grab credentials. And again, SMS here is just not a great mechanism, because the guys who built this and the guys who are using it never thought that SMS one-time passcode is going to end up in all these different places. And again, coming back to some US wireless operators, I can get access to this data just by logging into a web portal that's protected with just a username and password, which is painful. And then finally, going back to malware. And so at the top, getting access to a SS7 node and being able to infiltrate the network, that's kind of difficult. Downloading somebody else's piece of malware, mass distributing that, that's really where people are going. That's really the attack vector they're taking. And how does that work? Pokemon Go, right? So Pokemon Go got released in, 3 or 4 countries, and the rest of the world was desperate to get a hold of it. There wasn't actually any code in Pokemon Go that looked at the country code or the GPS coordinates to say, no, you can't run this because it's not available in your country yet. So if you could get access to the APK on Android, for example, and you could share it with your friends, hey, they've got Pokemon Go even though they don't live in a country where the store can deliver it to them. So what were people doing? They were sharing those. Hey, I've got Pokemon Go, download it from this website, whilst we're waiting for them to distribute it in the country. And of course, people were grabbing those copies. It's Java, decompile, stick your malware in there, off it goes. And then people are desperate to install Pokemon Go. They're accepting every permission under the sun. Sure, yeah, come on, let's get there. I want to get my Golduck or whatever it is. My kids are on it all the time. So people are just giving it permissions. Now on Android, which is unfortunately not quite as secure as iOS, you can allow apps to have programmatic access to your messaging stream, your SMS stream. So now you've got this Pokemon Go software running. Every time you get a text, it's programmatically capturing it and piping it back to some command and control center saying, look, here's all the tokens, here's all the SMS traffic for this particular phone number. And you're also probably typing in your username and password. They accept Google authenticated tokens, Google authenticated accounts. So you can log in with Google. So now I've got your username and password, and I'm reading your SMS queue. Hey, presto, I can now get your OTP. And I can automate the other end, right? I can automate some tool that's looking at accounts, logging into things. So it's pretty bad. And voice, I won't go into a lot of detail, but voice is kind of just as bad. So SMS and voice, they're really kind of as bad as each other. Voice has some advantages in the sense that it's much harder to programmatically get the token out of a voice call, but actually redirecting the voice call in itself is not trivial, but again, there are vulnerabilities out there. So a lot of these issues have been known for a long time, it's really about what's the ease of access. And when you look at things like this, that's the problem. Not the SS7 network, it's the fact that people can easily write a piece of malware. It gets distributed very quickly in an extremely popular application, and then platforms like Android are allowing those applications, as long as the user's accepting permissions, which we all know everybody accepts everything that the app tells you, unless you're the very, very small minority of us in this community that really reads that stuff. Everybody goes, yes, 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 fine, and then they complain about privacy and security when something goes wrong, because the user experience drives all of this. So, just take a pause, because sometimes when I'm doing these presentations, I feel like it's just doom and gloom, and the world's bad, and SMS is terrible. But remind ourselves that SMS for 2FA is better than just relying on a username and password. So I just want to keep that in everybody's mind. So what are the alternatives? So we could go back to the 1980s, and we could go use RSA tokens again. Why are they better? Well, because there's no communications. I'm logging into this application, to this website, and it's asking me for a secondary piece of information as part of the login. I pull out my RSA token, and the code it's generating is on my device. And it's time that keeps these two things together. So the token has some sort of secret on it. The server also knows that secret, and it basically is running an algorithm that, based on time, those two numbers should be the same. So if I give you that number and I run it through my algorithm, yeah, I've got the same number as you. You must have that thing in your pocket. But they're expensive. You've got to distribute them. People lose them. But we have made a little bit of progress here. So FIDO and the ideas of U2F keys and YubiKey, you can see here, is kind of like the modern day version of that RSA token. And what it's doing is it's allowing you to store the 2FA data on a device. And instead of having to read a token, you're essentially sticking it in the side of your computer. You're logging into a website. The website says, hey, go press the button on that thing that I know you've got connected to your device. And I press the button, and it releases the information that allows me to log in. Brilliant. Easier. I don't have to have 10 RSA tokens for each and every service that I use. It still requires a piece of hardware, which has a cost associated with it. If I lose it, I'm a bit stuck. How do I recover from that? But it's a little bit of a better user experience. But realistically, we don't want to be going to hardware tokens. These are great. I mean, when we deploy code to services, we have Bastion hosts, we use those tokens. But it's for administrators. It's not for your mass population. So what do we do next? Well, the one-time password is still a good idea. And if the vulnerabilities are in the delivery of it, move to generating that token, not in hardware, which costs you money to send, but write a piece of software that sits on someone's phone. So this really is kind of what, when I went back to that slide earlier with all the different people that were using SMS for 2FA, vast majority of them also do this. So essentially, you're sharing the secret with the device. Most often, people are scanning a QR code to get that secret onto the software. And now your phone offline can generate the token, and you tap that token in, hey presto. No problems with SMS communication. It's just better. There are downsides to this. So this is prone to phishing. So if I'm doing a targeted attack and I really do a good job of designing the login page for your company, I can fool you into giving me that token. But it's much, much more secure than the idea of sending it over SMS. Yeah, there's just a couple of examples there. But really, kind of the alternative to all of these problems is push mode authentication, which I hate that term because it doesn't really mean anything useful. But I'm going to describe what this does. And this is kind of, these technologies have been around for about a year. If you're sat there in the audience thinking, I'm going to go build the next big LinkedIn, the next Facebook, the next social network, this is where you start. And I'm also going to do a demo of Google and Yahoo and also some of our stuff to kind of give you an idea of how this works. But essentially what we're doing, that is a phone, it's difficult to see. Instead of, the advantages here are twofold. The first piece is user interface. So if I'm sat in a cafe and I'm having my coffee and I get that text that says, your Google authentication code is, I kind of go, why am I getting that? If I'm not logging into anything, that's kind of a surprise. And that's an important point, is that I get that message and I probably kind of guess, oh, I think someone's trying to log into my Google account. What do I do next? Who do I call? How do I tell that thing, no, that's not me. There's no phone number to call. There's no interactive user interface. So that's not great. And the second part is the vast majority of 2FA on websites is opt-in, which means you sign up for an account on Amazon, they may happen to tell you, hey, make your account a bit more secure by going through this set of menus down to here and find that thing and switch that button on, give us your phone number, we'll send you a text and all of that. So it's difficult to set up. And also the fact that you're constantly logging in, providing that token, the user experience isn't great. Again, it comes back to user experience. If the user experience isn't brilliant, then they're going to not want to do it. And we've learned that it's not great, so we make it opt in. So now we've got this problem where SMS, when I get it, I don't know really what it's telling me. I don't know how to respond to that. Plus, the companies are saying, well, you don't really have to use it if you don't want to, because we know it's a bit of a pain as part of the login. So how is push better? So what push is doing is, first of all, we're not using SMS as communication. So what we're doing is we're pushing a notification to the phone. So in the same way that your phone says, oh, someone's posted on your Facebook wall, or somebody has sent you an email, or I think some other example, yeah, your Uber's arriving. Now I get a notification on the phone, right? And I click on the notification, and it launches the application in question, and it shows me the data. So what we're doing here is we're sending these push notifications to devices saying, click on this, and there's a message, and here's the message. And the message is saying, somebody is trying to log into your account. Is this you? So there's a big difference between this and SMS. First of all, branding is there. So with SMS, I get this text message. I'm not really sure, is that Google? And remember, we can spoof a lot of that stuff, and it's easy to look a little bit like it. Here we've got the branding saying, this is your bank. This is what's happening. So somebody's trying to log in, and here's some detail. And the project's not very good. But you can pass in a whole bunch of information. And you might be geolocating the IP. You might have GPS coordinates from where the person's logging in from. But you can tell that to the end user. Somebody's trying to log into your bank right now. What do you want to do? Yes or no? This is so much better than any of the other mechanisms we've looked at so far. I can say, yeah, it's me. I'm sat at home. I'm trying to log in. No problems. Click approve. Second one is, no, it's not me. Deny. And that means at that point in time, that access to that website has been prevented because you're literally saying, no, don't do this. So the user experience is much better, and it's a lot more secure. Why? Because the communication between the device that's presenting that question and the service that you're using to talk to it is all protected. It's all going over IP. It's all using HTTPS and signing certs, signing the messages and everything. That communication is designed to be secure, unlike SMS, which is just fire and forget and hoping it gets down there. So it's a much, much better way to do it. So let's have a look at how this works. And this is where I'm going to, evidence. So who's doing this, right? I said it's been around for a year. Yahoo Account Key was probably one of the first I saw doing this that was mass open to consumers. Kind of ironic considering the news from Yahoo in recent weeks. Google Prompts, they have, in fact, both Yahoo and Google have gone one step further. And they're saying, 2FA, forget 2FA, use this for primary login. So with Yahoo, when you set it up, they will say, you want to use Yahoo Account Key? Sure. Oh, you've got Yahoo installed on your phone. Use this for consistent login. So they're not getting rid of the password. We're getting there as an industry, but we're not quite there yet. But with these first two, Yahoo Account Key and Google Prompt, what they're saying is, don't give me that password every time you're logging in. So if you have got a compromised desktop, they're going to need to compromise the phone as well, because you're not typing in your password every time you log in, so they can't capture those credentials. So the password's still on the account, but it's used in less and less occasions. It's used maybe for account recovery when you lose your phone, and it's maybe used to install the device in the first place. But we're not consistently using it in places where it can be captured and reused against you. And so Google like, great, well, let's use that as primary login. You just type in your email address and boom, and I'll show that in a second. Salesforce Lightning Login, I call that consumer identity because it's kind of like a SaaS service providing access to millions. And it's even creeping into the financial space. So Capital One, maybe because I don't have enough money in my bank account, I've not been able to switch that on myself. I think they only provide it to high value and high risk customers, clearly not me. But according to their website, there are certain things you might do a transfer in your account. You might be changing your home address, which is sensitive information, and they will be sending a notification to your phone saying, hey, this is happening, is it really you? And then on the opposite side of the house is technologies and companies that are providing this as part of IT infrastructure. So Microsoft classically, Office 365 and on-premises technologies, they have the capability to do push. Okta, cloud identity platform. Duo, a cloud 2FA platform. Symantec, we all know Symantec. So consumer identity is great because we're getting that to millions of users. Enterprise identity is great because we're getting that to hundreds of thousands of employees. My technology sits in between of those. It's just an API. So the problems with using some of these on the left, if you're building an application and you want to use better authentication technologies like these, you could use Google Prompt, but you're kind of releasing your branding, you're releasing your users' potential privacy information to Google. Not everybody's keen on doing that. And then with the enterprise identity side, again, the ability for you to configure and kind of embed that whole experience into your application is a little bit more limited because they're kind of sitting at the front door at that single sign-on login. So let's have a look at some of this in action. So, Santiago, did you send me your, can you send me your Auth ID? So a friend of mine has just walked into the room who's going to help me with a bit of a demo here. Okay. So this is where I figure out if I can, I'm just going to change my displays because, oh no, it's worked, fantastic. All right, here we go. So I've got my iPhone running here on my desktop and I've got Yahoo Gmail. So let's start with Yahoo. So as I said, what I'm going to do is I'm just going to log in. I'm actually going to use it for primary. So I'm going to click on sign in. I just type in my email. It's AppSec 2016, I think, at yahoo.com. And they're going to look it up and they're going to go, oh, actually, you've already registered a device. And I'm just going to send a notification to that device. And I'll flip over here. So here we can say, you're signing in as so-and-so from Firefox. Yes, I am. I open up their application. And here we can see some of that really rich UI. Come on, wireless. There we go. Just a bit of delay. Are you trying to sign in? It's Simon Thorpe. Some of the details down the bottom there. It knows I'm in Washington, probably geolocating my IP address. I'm going to say yes. And notice how, did I respond to that? Yeah. When I respond to it, it's a back-end call to Yahoo. Now I'm logged in. So this is a really good user experience. So all I'm doing is typing in my email address. My phone says, hey, is that you? I click yes. I don't even have to touch the browser. And what's happening there is communication from the application. So I type in my username. It then does a back-end push notification. It goes, what type of device? Oh, he's got an iPhone. Let's talk over what's called APNS, which is the Apple Push Notification Service. Send in this notification. Tell him to fire up the Yahoo Mail or the Yahoo News client that's on his phone and present him with this option. When I respond to that, the phone is then talking back to Yahoo saying, hey, that guy just logged in. Yeah, he said that's okay. And we just, a socket, so whatever the connectivity is back to the browser, it just logs me in. Really, really good user experience. So let's look at Google doing it. Oops, I preloaded that. So I've got my Google account here ready to go. I've already got my password. So again, this is more of a 2FA. So Yahoo, I didn't type my password in. I just went straight for it. Google, you can actually configure it with Google to be primary, but I just thought I'd demonstrate the 2FA side of it. So here I go, sign in. And if wireless, yep. So there's my message. I click on Google. Let me pop that up. So now this is hopefully communicating to Google to get the message. Come on. Oh, didn't like that, did it? Of course, I do this 5, 6, 7 times this morning whilst having a coffee, and network connectivity is great. And here's one of the downsides, actually, and I'll get to this in a second, some of the limitations of this. It does rely very heavily on having a decent network connection. All right, so Google's not going to like me. Let's see. Yeah, and actually, I'll just put this out. So it is important here. You can see Google is presenting. Actually, it's good that this didn't work because I wouldn't have shown this otherwise. So the fact that I didn't get that push notification, the fact that my phone is struggling to connect to the wireless, and I think I know why. It's trying to connect to the room wireless, and I don't have access here. You do need to step back. So did you get that? No? Okay, here's some alternatives. And one of the alternatives, of course, is getting a text message. Right? So that's important because what we want to do is, I'm just going to switch off wireless on my phone. So I definitely get it. Oh, it is off. Huh. Oh, it's because it's connected to the, yes. Yeah, because you want to be able to fall back from not having an IP network. And again, going back to being on a plane, being on Wi-Fi, I often use my laptop as Wi-Fi on the plane, but I don't always connect my phone. So if my phone can't get those messages and I'm trying to access secured resources on the laptop, I need a way to be able to do that. Now, with SMS, I can't, but there are other alternatives, such as the TOTP you mentioned earlier, which can be generated offline. So let me show a slightly different one. This is just one of the demo platforms that we have around our technology. And the reason I want to show you kind of what we do is there's a couple of interesting ways that you can use this type of authentication, not just for the front door, but actually inside the application itself. So first I'm going to log in. And again here, fingers crossed, I get a notification. Yeah. Oh, actually, so you'll see two things. I've got a notification on the phone. And if I just do that, you can see here the request come up on my phone. It's going to need Touch ID. Oh, network. Actually, so let's go. So I also have the same thing running. Yeah, it's going to wait for Touch ID. All right, ignore that. I also have a software client, so I can have the same experience actually running in a Chrome application. So I don't have to rely on my phone here. I can do it from the device. And if I click on Approve, again, that's going to send a callback, and you can see in the background that request happened really, really quickly. But the reason I want to show ours is just because I have a bit more control over it, and I wanted to show you other ways that this type of authentication can be used. So here we have escrow. Let me just pull up, write down a number, 5854658. All right, this is a little clunky because I'm just basically demonstrating our technology like this. So if I type in that, so you would typically be doing this in code and not writing it into the interface. What I've got here is there's my identity, which is my Authy ID, and then I have somebody else's Authy ID, and that's Santiago here sat in the audience. I'm going to transfer $150,000. 1, 2, 3. Deposit for the house. So what we're doing here is we're showing that this type of push, this ability to me to reach out to a device and say, hey, something's happening, do you want approve or deny, is really useful beyond that initial login. So if you think about having a compromised desktop, there's a lot of Bitcoin companies that use this. And what they do is they have this type of functionality in the application itself. So if I've logged on to my environment, I've approved, but I have a compromised desktop and I go, go use the restroom, go make my lunch, somebody could be accessing my desktop while I'm away in an existing session, and they try and do something like, right, let's start pulling the Bitcoin out of his account, or let's start sending money out of his bank. And when we do that, we get a notification on the phone. So something happening in the application, a transaction, and now we're getting notifications. And here I'm going to do it on my software-based. And if I approve, again, a callback hits the service, and if Santiago's Wi-Fi is working as well. So I approve that, and now we're waiting for another third party to respond to the same. Is it getting it? All right. There we go, it worked. So the point here is, all this is, it's not necessarily about logging in. It's just a tool for you to be able to reach out to a registered and approved device and say, something's happening. Is that you? Do you want to approve it? And you can actually extend that to multiple people. And a gentleman's coming up. Got a question?
Yeah, just for the other folks here, there's a couple really good points about this approach as well. If you've dealt with your risk organizations that say, oh, SMS, OTP, or token is the way we do it, you can't do nothing else, you can turn around and start this from a fraud prevention perspective. You say, okay, I'm not using it as authentication. I'm using it as a way for the client to say no. A classic use case is, hey, Joe Rich Guy, we set up your credit card to work in Budapest when you're there next week. I'm not going to Budapest. My son with the drug habit is doing it again. So, however, your risk organization will say, yeah, I could save a couple $1 million a year if I just gave people an easy way to say no.
Right.
The other issue is the client that maybe you're setting up because you're in a bank or you're in some other regulated industry, you make your client sign something to say, we're going to track where you go, what you do for the main app. And they're like, get out of here. I'm an old rich guy. I'm not going to tell you where I am. But this lightweight client that you could be putting out here that just has the ability to say no, just has the ability to say, call my banker or whatever, you could put out without any of those constraints. So you're getting some feedback to your clients where maybe your take-up is only 30% of clients, the young people who don't have the money yet because the old guy's not dead yet.
You should come up here.
No. So you put this together, and it's just a way you can start out, and then eventually, once someone in the risk side says, "Oh, this authentication method's being done at 2 other banks, I'll let you do it too."
Right.
You just snap it on. So sometimes you can't win the battle on day one. You say, "Oh, let me in a little bit," and before you know it, the camel's living in the tank.
That's a good point, and I think that's where we're seeing traction with the Googles and the Yahoos. Why? Because they have millions and millions of accounts and they control, and they want to lead the way in giving us better authentication solutions. But the fact that Capital One have deployed something like this I think that's really significant, that the banks are also finding ways. Because my bank in the UK, I live in San Francisco, but I still have a bank in England, and they send me this card reader, right? How much is that costing them to send out card readers to every single customer? And I'm not a high-risk customer with them. I've got like a couple $100 in my account.
The other control in a lot of shops, the control is a callback.
Yeah.
But guess what? You just automated the callback. I think about, okay, we set the whole thing up. I went through the monkey dance with the one-time password, and now I have to call you back because you've never sent money to that beneficiary before. Right. And I'm in the board meeting.
Oh, now you're leading me into a sales pitch. So,
right. But I could be sitting there at this thing saying, yeah, I really did want it. And do whatever you need to do to satisfy the callback requirements without picking up the phone.
So imagine it not just being approve and deny. And this now kind of, again, I hate kind of getting into how our technology works and make it sound like I'm pitching this, but this is a communication system, right? I'm communicating to you, asking for a decision. The fact that it's really secure is almost arbitrary. But imagine if that approve deny came with a contact support. And think about all the data that you have at this point in time. And I'm sat in my coffee shop, and it says someone's trying to transfer $1 million. Is that you? Approve deny. Contact us. In fact, there was recently. I always forget the details. There was a gentleman who was attacked because someone was typing into Amazon support information about a delivery. Oh, I don't know, where's my delivery? It's not here yet. Can you remind me where it's going to? Trying to get address details out of Amazon. And after a couple of attempts, he got enough information out of Amazon to be able to start using that data elsewhere. And while this was going on, he was getting emails saying, thank you for your support chat with Amazon. So I didn't talk to Amazon. What the hell's going on, right? So after the fact, he was getting this communication from Amazon saying, oh, I hope you got your package. It's like, no, what? And then he started to see other accounts drop and the walls were falling down. Imagine if you were sat there and you got a notification saying, you are talking to Amazon customer support. Is this you? Yes or no? Contact us. So now I've got somebody calling into the support desk, doing that social engineering, trying to do that SIM swap and trying to spoof the SIM card or take over the SIM card for your account. And part of that, what do we do today? We call it, what's the last 4 digits, your social? We're still doing that. That's 30, 40 years old. Your phone pops up and says, you're talking to customer support, is it you, yes or no? And there's a button that says call. You click on that button, VoIP connection made to the bank, to the person on the phone with the person who thinks it's you. That customer experience, you just can't beat.
And in that use case, when you clicked on that, if that's your bank application with any kind of basic level of authentication, when it comes into their desk, they say, yeah, it's a call from Joe Rich Guy, and here's a token to say it's coming from Joe Rich Guy's phone.
Right.
So you got more.
Right. And it's not perfect. Joe Rich Guy could be there with a gun to his head. Somebody says, unlock your phone. Okay. There's always ways around this, but this is a significantly better approach to sending a text to somebody as part of a login, which you've been doing 15 years. So this is a much better way to do it. So SMS, it's done, right? Bye-bye? No, unfortunately not. So as you saw with Google, I didn't get the message, right? Yahoo worked, Authy worked, but Google just happened to, perfect 15 minutes, Google just happened to not have the I didn't have the wireless connectivity to that point. So this is all about fallback and about balancing risk. So if you're deploying this, try push first. But Google's smart enough to say, do you not get it? Well, let's try another way. Fall back to something that isn't SMS. So if you're distributing hard tokens, use them. If you've implemented TOTP in a client, use it, right? Don't fall back to a communications channel. I can't remember quite how Google did it. I think SMS was number 2. I would say hide that thing as much as possible, but it's still got to be there, but it's a last resort. Last resort because when I travel to our development office, I switch off data on my phone because it costs a fortune. If I power my phone up when I land, boom, my email syncs and I've just spent $50. I switch it off. And so SMS, I still get SMSs. So it's still a really, really good last resort, but try everything else before you do that. What if you've already built SMS? What if you're sat there going, well, dude, I just spent the last 6 months implementing a whole SMS solution. What do I do now? So first of all, this is all doom and gloom, right? It's a security conference. Oh, SMS is bad and people are attacking your accounts. But evaluate your risk. Are you protecting something like a web forum for cuddly toys? Do you really need like super security? SMS is probably fine to protect people logging into your cuddly toy forum. Are you an online Bitcoin exchange? Probably don't want to be using SMS as a primary method of authentication. So you're all smart. You know, juggle your risk with the appropriate mechanisms to secure access. Use TOTP, right? So if you've built SMS today, adding TOTP isn't rocket science. There are hundreds of libraries on GitHub you can go pull. The algorithms are all standard. There's loads of free clients that your end users can use, so you don't have to modify your own application. Google Authenticator, Microsoft, we've got one that's free. Duo's got one. I mean, there's loads of clients that people can download, and lots of users are starting to get savvy with this, the process of capturing the QR code. So that's a good mechanism, and it's out of band in the sense that there's no communication to the device, apart from that initial secret passing. And then migrate to a service. I mean, this is something important to your application, and there is plenty of libraries on GitHub, but I think the third most popular library on GitHub has 2 contributors, and one hasn't done, you know, they haven't done anything in the last 12 months. This landscape changes quickly and often. There are even things within SMS itself you can actually do to get a better risk score of, well, you know, you can dip things like HLR data to see, well, is this a roaming device, and where's it roamed from? And there's lots of stuff you can do that. Are you going to be, you know, are you building an application where you're constantly looking at your 2FA information? If you migrate to a service and just use somebody else's, they are constantly looking at the security of that platform, the availability of that platform, and bringing you the best features as soon as possible. Again, a little bit of a pitch, I apologize. So, reminder, username and password, no good, let's stop doing that. Security via SMS, so you now have a bit of an idea of whether that's a good mechanism or not, and we're kind of agreeing it's not great, but remember that both of these together is better than nothing. It's better than just username and password. Okay, all right, and then I'm pretty much done. So, just to summarize, because my methodology is keep telling you the same thing over and over again. So, in your application, try and prioritize the best and most secure 2FA option possible. Fall back to SMS as an absolute last resort. And seriously, I'm going to keep saying this. It's better than just username and password on its own. I'm done. I think I got like 5 minutes. So thank you, William, for your interjections. They're much better points than some I was making. Any questions from anybody about how to do this, how it works, how secure is it really? Gentleman down here. Oh, actually. All right. Nadeem and a gentleman walking up to the mic, so.
I'm just curious about the technical details of how does the push to the customer's device actually working. If you can give us just an idea.
Yeah, real high level, how does that actual whole push thing work? So first of all, let's say you build it yourself, right? I've got this, I built it for you, but let's say you're going to do it yourself. The 2 most popular devices out there are Android and Windows Phone. Sorry, and iOS. Wow, I did used to work for Microsoft, so that was a genuine slip. The Kool-Aid is still in there somewhere. Yeah, Android and iOS. So both of those providers, Apple and Google, have messaging networks. So with Apple, it's called APNS, the Apple Push Notification Service. With Google, I keep rebranding it, but it's Google Cloud Messaging. I think they gave it another name recently, I can't remember. So both of these, you need to know, when you register that device, you need to know what type it is. So you'll figure out, oh, this user has this Android device, here's the user identifier, here's the record for the device, I know it's Google. They're logging in, you send a message onto that notification service, either Apple or Google. Microsoft does have one. And actually there are some companies, so like Amazon, and actually Twilio has something called Twilio Notify, which allows you to say, I just want to send this message, and they'll figure that out for you. So people are aggregating up these networks into a single endpoint. But now your phone gets that message, it's got to connect to the software on the phone. So you need to write software on the phone to communicate to the server. So I basically click on that notification, it's got a payload, it's got some sort of identifier that says, hey, this identifier carries information about an activity. You select that, the software starts. Software then needs to communicate securely back to the server, say, hey, I've got this identifier, what's going on? The server goes, oh, right, you're Simon's phone, here's what's happening. It sends me the logo, it sends me are you logging in? It sends me all the details, and it displays it, and it goes, right, okay, so that's what's happening. So that's the hook, right? So notification to the phone with an identifier, secure communication back to the server to get the content, and then render it on the end user's part, and then the end user replies, approve or deny, and then that goes back to the server. Now the authentication service or 2FA service has got a response from the device. It then calls back to the originating application. So the thing that was doing the login then gets a message saying, hey, this guy said yes, he said no, here's the details of what he did. Now, depending on the technology in that communication, you might get, he said yes on an iPhone, he said yes on an iPhone from this IP address. So now you can start piping that data into your own fraud analytics to say, even if my device was compromised, or I might be traveling, so it might be that I'm legitimately approving something in another country where the risk is higher, you might then say, well, I'm not going to accept that transaction over $150,000. I'm actually going to lower that bar. So you're getting a lot of information in that callback as well, which is extremely useful. Does that answer your question? Cool. And a gentleman was... There's one more.
So this has been my job for like the last year.
Oh.
Going forward for another year to get our entire member base into 2FA. We're going to force. So we've been forcing all new members into this. And we go SMS first, and then email. We've got a token embedded in our app, so we're going to force that as well.
Gotcha.
Two big questions though. So our big problem with push. So we tried push.
Right.
We did a pilot of it. The two biggest problems were the timeliness of the push notifications and then device management. So you have two people owning a bank account, two spouses or whatever. One of them's logging in, and then you push to both devices, which you don't have a great. You need a really good interface to say which device do you want to push to.
Right.
So you push to both, and the spouse goes, "I'm not logging in." They hit deny, and then
Gotcha.
the person gets
Interesting.
kicked out. That's the first one. So I don't know if you've got a great solution for that. And the second one is what we call the low tech, no tech people. What do we do when you don't have SMS? You're deployed on a boat out in the middle of the ocean.
Gotcha.
Like
Okay.
That, you don't have a hard token, but you don't have whatever.
So about 3 questions. So first of all, yes, this is absolutely, and actually I'm really pleased it failed because that demonstrates the point. You have to have an IP connection. Without that, this doesn't work. And so yes, that's, again, this isn't, there's no silver bullet in any of this, right? There's no silver bullet in security. There's no, hey, encrypt the database. Oh, I'm done, right? You've got to go all the way through the application. You've got to look at the front door. You've got to look at the clients. It's a constant battle. So yes, not perfect. Wireless connectivity is a problem. In America, even in a hotel room, 2 floors down, I'm struggling to get Wi-Fi. So fall back. What do you fall back to? The guy on the boat, offline tokens. So generating that, and that's been, that's solid. We've been doing that for 15, 20 years. So there's no rocket science in that at all. Your other question was, multi-device. So again, try not to be too salesy. We could solve that problem with our technology. So each registration would have a separate ID. And actually, I kind of demonstrated it. So the escrow feature, we both got notifications because the logic in the background, I typed his identity in, his the number that we store, and there were 2 calls for each device. So what you do is when you register a device, you register that device to an identity, and if it's a shared bank account, now if they're sharing the same username, password, same record, same identity, that could present a problem. And I believe we have, there are some ways to get around that. We're actually going to be adding something that says within this set of identities, here are the devices, these are the ones I want to choose. Because one thing you notice with me is I was able to get that notification on my desktop in Chrome. That's a really awesome user experience, but it's really not good if my desktop's compromised. Because now the 2FA has gone away, now it's 1FA. Because now I'm executing the actual second factor in the same processing space as the thing I'm logging into, somebody could click that. So there are ways that you can basically say, this is a high-risk transaction. I don't want the device that's coming from the same location as the browser. I want it to be an actual separate physical device and not that Chrome instance.
Just kind of quickly along those same lines, could you also, or does your company offer, or is this a possibility to require multiple devices to authenticate?
Yes, that's exactly.
He was talking about the old rich man, and
Yeah.
what if your parents are getting a little old, and maybe literally, I'm thinking about this for my parents. They're getting old. They've got money, right?
He's changing his address
and
details.
require
No.
a kid or some trusted person to also say yes. Dad's trying to send $1 million to Bangladesh or wherever.
Absolutely, and in fact another example of that, and I'm not going to get kicked out for going over. So if I just switch this to gaming, so another example what you're talking about there about father or parent and child relationships. So I'm just going to log in here if I can remember my login. I think it's Simon Games, Simon Gaming. Oops, unlock my phone.
So essentially requiring multiple guesses for this action.
Yes, and if I can figure this out real quick. I'll register, that's what I'm looking for. Here we go. So let's do AppSecUSA. Something at something.com. It's all irrelevant. One. And please don't take my phone number. All right. Oops, I'm trying to touch my screen. That's not going to work. Yeah. So in this example here, I'm now. Let's say I'm the dad, and my kid. Oh, you can't see it. Stupid. Sorry. Here I am talking away, and you can't see what I'm doing. It's PowerPoint switching me to. Right, here we go. Right. So here is. Does that mean earlier when I was demoing this, you couldn't see? No, you could see it, right? So I've logged in to a gaming website as a child, and I want to purchase something. So I click on, I want the 30 feather pack, but the request goes to the parent, right? So the parent's sat in a coffee shop going, your child wants to buy, does it say, approved purchase of 30 feather pack for $30. Oh, no. Sorry, buddy. You didn't do your chores this week. So yeah, and then that comes back to the comparison. So Google Prompt and Yahoo account key, they're awesome, but they're difficult to use in your application because you can't build these use cases. The enterprise identity guys, like the Microsofts, the Oktas, they're awesome if you're protecting access to your online sort of business applications. What we have is just an API, right? And you do whatever you want with it. We're just providing you with a core functionality. So you can do internal escrows, you can do approval of address changes. If your account, the gentleman's over a certain age, then yes, he has to have approval from one of his siblings. You could do, one of the ones we did for fun was server reboots. So to reboot a high-end, front-end application server that's serving requests, you need at least 3 administrators to respond to their phone before the thing actually reboots. So it's an API. You do whatever you want. You can embed this wherever you want in your system. It's totally open. Again, I shouldn't be selling. I'm trying to talk about technology instead. All right. You want me to? Or no? 5? Any more? 3 more? No? You're all just wondering. Oh, there you go.
It took me about halfway through the presentation to realize you're Authy.
Yes. Good. That means I'm not trying to sell. I'm just trying to talk about technology.
Yeah. No. Good job with that. I use LastPass.
Oh,
I
right.
really like it. And I use Google Authenticator.
Mm-hmm.
And I've looked at Authy a few times, but Authy and LastPass together kind of scares me.
Yeah.
Because I use a Chrome extension for LastPass. I have it on my phone. I probably have it somewhere else. I forgot. And so if I use Authy, well, okay, I have a Chrome extension potentially. Then I have it on my phone. There you really have a one-stop shop for getting access to everything. And so do you have any advice or guidance to say password manager users to
So Santiago is a gentleman here in the audience. He's one of our security officers for the team. And his advice would be, I can feel it in his energy, don't use Chrome apps, right? So I'm demonstrating this Chrome app that we have, don't use it, right? So if you are using a password manager that resides on your local machine and your 2FA is also in Chrome, yes, absolutely, you're exposed to malicious attacks. We are adding a bunch of features to our service to put in some logic behind that, saying, okay, so you're on this browser and we probably wouldn't allow that request to go to that device due to the location where it's running. And you're on the sort of forming edge of people that are realizing this. You see a little bit of noise on Twitter, but I think the general population is starting to realize password managers have almost got to the point now where my mum probably uses one. So now we're starting to see people go, hold on, now I put all my passwords in this big bucket here, and the way to get access to those things is in this other big bucket, and if both of those buckets sit on the same compromised laptop. So yes, I think we're starting to introduce a lot more security around that. We watch what's going on in our system, so we're not seeing a lot of examples of those things happen, but absolutely, advice to yourself and other people is don't run these things in the same process. And we're actually going to be next year, shouldn't really talk about roadmap stuff. We're going to migrate out of Chrome and we're going to do a slightly different desktop approach to give us more control over that functionality.
Yeah, that risk is the same thing when someone turns around and says, oh, I'm going to move the 2-factor authentication into my app. Okay, app is owned through malware, so it's a 2-factor authentication.
Yeah.
So, keep something separate. Our authentication client, which is the notification client, is ours. We wouldn't have that as a third party.
Right. Yeah, and we've got, there are SDKs you can put in your applications to have more control over it. There's no silver bullet here, and I know what you're talking about as an end user with a password manager and 2FA running in the same space, but a lot of this is about, are you protecting a cuddly toy forum or are you protecting a massive Bitcoin exchange? So there is, massive Bitcoin exchange, let's put lots of policies in, so you can't do certain things, you can't run the Chrome app, you can't do these certain things. Cuddly toy forum,
We'll take one more question, and then any other questions will be offline because we need to get the next speaker mic'd up. Thanks.
So notifications, sent to the phone. I'm guessing that you can use the Android or iOS platform for authenticating that. It's that actual user. It's not somebody else installing this app on their phone and being like, oh, I am this user. What do you do for like a Chrome extension or a desktop app for establishing the user identity?
That initial trust. We have several mechanisms, and those mechanisms are constantly evolving. Because guess what? One of those mechanisms is SMS. And I've just spent the last hour saying, don't use SMS. But so for new accounts, for that initial first installation, typically the risk scenario is much lower. Like they haven't even created an account. They haven't even got any Bitcoin. So sure, we'll let that first instance of that come over an SMS. So you might use phone verification. I'm going to send you a code to this number. Have you got that number? Yes, you can do the install. What we actually do is subsequently to that, you can't, for high-risk customers, again, so we're trying to look at what's the risk. So for some people, you can keep using SMS to register new devices because it's low risk. For some customers, it's like, no, you have to use another device. So once you've got your first device installed and you want to go install the Chrome app, the only thing that can validate that installation is the other device that you've just registered. So we go cross-device. So there are ways to type of mitigate that. There are some mechanisms like Roku and other kind of household devices. They'll use a pairing code. So you're authenticated to a web session. To add another IoT type device into the mix, you stick your Roku and on the screen it says type in this code. YouTube do it with adding YouTube clients to your service. So that's another way to do it, is using pairing codes. But yeah, again, there's no silver bullet there. It's lots of different options.
Thank you.
All right, cool. Thank you very much.
Thank you, Simon.
All right.